Okay, objective 5, I know we said in class we didn't need to do this, but I thought I would just add it along with objective 8, which I apparently forgot to record. So if you want to listen to this, welcome. So the effect of adding or removing a product, we just talked about adding or removing a reactant, and because we're usually talking about the forward reaction being the one we want, and we're all about increasing yield, which means increasing product, increasing the forward reaction, um, that means that adding a reactant is a good thing to drive it to the right. And so then adding or removing a product is going to have the opposite effect, or for the same reason. When you add a product, you're going to increase collisions on the product side, so more reactant forms, and you'll drive your position left, even though Kc remains the same because your ratio is the same. So usually when we're talking about the forward reactant, adding a product's a bad idea. Instead, what's far more commonly done is to remove that product, because then you'll decrease collisions on the product side. So in comparison, the reactant side will have more collisions. More product will form to replace the decrease or the loss, the removed product, and your equilibrium position will shift to the right. But again, your equilibrium constant will remain the same since both reactant and product decrease and that ratio is unaffected. And then number 8, if I scroll down, asks about the catalyst. And you guys seem to have it down that there's no effect on equilibrium position or the equilibrium constant when you add a catalyst, that it affects only the rate. But IB almost always wants you to explain why that is. And it's because a catalyst lowers the activation energy, which only affects the reaction rate, because lowering the activation energy is going to affect the forward and the reverse reaction equally. So your explanation or reasoning can be either because it affects rate by lowering the activation energy, or it affects rate by affecting the forward and reverse reactions equally.